Our next presenter is David Simons. Mr. Simons is the co-manager for the Texas Optimization Program, and he serves as an engineer for the Texas Optimization Program and Response Team. He received his Bachelor's of Science and Master of Science degrees in Civil Engineering from UT Austin. David worked for an environmental consulting firm in Dallas, holding engineering positions with the cities of McKinney and Taylor, and worked for a civil engineering consulting firm in the Austin area prior to taking his position with the TCEQ in 2013. In addition to the administrative duties for Texas Optimization Program, he provides technical assistance to public water systems, TCEQ regional offices, and conducts on-site evaluations for surface water treatment plants. His primary focus from 2018 has been low-pressure membrane treatment plants. So give him a hand for being here. Sorry, bud.
All right, so today we're going to be talking about free chlorine conversion strategies, and in particular a guidance manual for doing temporary conversions to free chlorine if you're a system that normally uses chloramines as your disinfectant, residual, and distribution. We've seen different water systems do free chlorine conversions successfully and not so successfully, and so we've assembled the successful strategies for you in this guidance document, and I hope you'll refer back to these materials if you have a free chlorine conversion planned in the future. All right, so here's an outline of the presentation. Talk a little bit about the free chlorine conversion guidance manual, and then we'll go through the highlights of the manual. And most of the stuff that's in the manual are in these slides. So if you have the slides, you've got most of the materials already. Now the guidance manual, I tried so hard this year to get the thing finalized and have the official version ready for y'all, and then they threw me a curveball and said, nope, we're not doing that kind of document anymore. You need to change it to this other one. And so we still only have a draft version of the guidance manual, unfortunately. What's important about the guidance manual, besides what I'm going to talk about today, if you look at the appendix, there is a bunch of information that will, some charts and stuff to help you figure out, for instance, if, is your existing equipment, say chlorine injection equipment, sized to do a breakpoint chlorination? If you're a booster plant or you have a booster plant, you're receiving water that already has chloramines in it. Most of the times those booster plants don't have enough chlorine injection capacity to actually take that water through breakpoint. So that's a real helpful tools in the back to help you work through those issues there. All right, so what are some messages for today? I assume most of y'all are using chloramines to maintain your disinfectant residuals. And honestly, the primary reason people use chloramines is so that they can comply with the disinfection byproduct, the TTHM and HAA5, those requirements. If you are in a chloraminated system, you can have nitrification, which can cause residual loss. And temporary conversion to free chlorine is one way to stop the nitrification. And some of y'all may refer to it as a free chlorine burn. So we're talking about the same thing. So who needs a temporary conversion to free chlorine? Every PWS with chloramines can have nitrification. So every PWS with chloramines, may need to have a temporary conversion to free chlorine. We at the TCEQ don't like to hear it called a burn because you're not really burning anything. I mean, you're just changing your residual. So conversion is more accurate. Burning may not sound positive to your customers. Up to you if you use it or not, but we just prefer not to say we're burning their water. Another term I have heard is free chlorine refresh. If that sounds better to you than conversion. So, little disclaimer before we jump into this: the nitrification and the biology behind it and the chloramine chemistry, they're pretty complicated. I am going to assume that you have an understanding of how to identify nitrification, as opposed to other causes of low disinfectant residuals. And then this presentation is going to focus just on, the actual strategies for conducting the free chlorine conversion after you have determined that what your problem is actually nitrification. So what is nitrification? So there's certain bacteria every distribution system has them. Our distribution systems are not sterile. There are microorganisms out there, and certain ones of them use ammonia as a fuel. So they eat the ammonia, and they make more bacteria, and if you get enough of them, they exert a demand on your total chlorine or monochloramine residuals. And then, of course, that demand makes your total chlorine and monochloramine residuals drop. So the low disinfectant, when that does happen during nitrification, can cause persistence and regrowth of bacteria. And the bacteria that use ammonia, they are coliform bacteria, so they can show up as a positive in total coliform test. Of course, once you have low residuals, other microorganisms could become established in the distribution system and cause potential illness. And everybody's favorite, and TCEQ may give you violations for having low residuals. So try to avoid it. So how do you stop nitrification? You have to remove the ammonia from your distribution system, and you're taking away the fuel, and you starve the bacteria that eat ammonia. And the conversion to free chlorine does eliminate all free ammonia in the distribution system. One note I'd like to make, though, is if you have a chloramine system, just assume you have at least a little bit of nitrification happening all the time. When the water is warmer, the bacteria multiply more quickly, and you see the worst effects. But even in the winter, there's still some bacteria there, and they're eating ammonia. Most of the time, you should be able to limit the effects of the nitrification, control it with actions that are less severe than a free chlorine conversion. But if you do need to stop the nitrification completely for a short period of time, you have to get rid of the ammonia from the distribution system. All right, so we'll go through some pros and cons of free chlorine conversions. It actually works. It is the only way to starve bacteria that eat ammonia. The free chlorine is not directly killing the bacteria. The residuals aren't high enough, but it's taking away their food source. So think of it that way. Just a little bit of exposure to free chlorine isn't enough to kill those bacteria. You actually have to give it enough time to starve the bacteria to have an effect. So that's that rule that we have here of 2 weeks of exposure is a good rule of thumb. And that means 2 weeks at all points in your distribution system. If you start it and it takes 5 days for the water to get to the end of your distribution system, you start counting 2 weeks from that point on. That's a good rule of thumb. And then, of course, you'll have the time you need after that to restore it back to monochloramine. So I've already said it, but just want to remind you, ammonia can't be present, at least not to any measurable degree, when you have an actual free chlorine residual. And so even if you're sure you've got a free chlorine residual, but you're reading free ammonia and it's still like 0.05 milligrams per liter, you'll just have to accept that that's really a zero reading. It's close enough to zero to call it zero. You may never, just because the reagents and analysis methods, have a little bit of error in them, it may tell you you've got a little, but when you have free chlorine, you don't have measurable free ammonia. So this is both a pro and a con. The free chlorine conversion only works if the problem is nitrification. And we've already mentioned, there's other things that can cause low residuals. I'm not going to really talk about those in any detail today. There are other TCEQ presentations, et cetera, that'll give you tips on, how to determine, is the problem, a treatment failure? Do you have some increased demand in your water? Do you have a cross connection or unstable chloramines? And, if it's any of those things, a free chlorine conversion isn't gonna help you resolve those issues. So again, just key is you need to, before you do this, make sure you actually have nitrification. All right, so a con, and this is a big one. It works when you do it right. And by that, I mean, it's going to take more work by your operators to determine, how much chlorine are they going to need. They're going to have to spend time setting up, maybe delivery supplies of chlorine. and doing all that coordination with your suppliers. They have to go out and check that the valves are working. Another issue is during the actual flushing, when you're moving free chlorine through your system, there's a lot more work for the operators than they normally have. A lot more monitoring, both during the start and at the end. So keep that in mind. To do it right, it is going to take more time, and if you'll have to have overtime, budgeted, you may have to do that. Another con is the potential odor calls. If you don't flush the free chlorine through the system quickly, there can be areas that have basically unstable chloramines, dichloramines, and trichloramines, and those smell bad, and your customers may notice that. So in this figure here, I just want to be clear, as the free chlorine is moving and displacing the monochloramine, there's always going to be this zone between them of unstable, stinky dichloramine and trichloramine. The goal is to make that zone as small as possible. If you make it that zone last a whole day at somebody's house, yeah, they're going to notice. If it's only there for 30 minutes before it converts completely over to free chlorine, that may not be a big deal. So again, it's just emphasizing that doing this quickly and efficiently is going to help you on just the complaint side. Other odor call issues, just having free chlorine in the system, that residual tastes different than your normal chloramine residual, and some of the customers may complain. So it's always a good idea to try to set their expectations ahead of time. Yes, the water is going to taste different, but it's perfectly safe. It's not going to burn your skin or anything like that. Is a good idea. So you could have color issues, and if you're doing extra flushing, free chlorine can stir up sediments that are settled in your distribution system, and can also oxidize metals, resulting in color. We recommend that before you start the conversion, you do a good job of flushing out all the sediments out of your system, and make sure your customers know, hey, yeah, we may have a little color as we're cleaning this out, but we're doing everything we can to make you have good, safe water, good water quality. And it's typically the public water systems that have iron and manganese issues that this is an issue. And those systems, sometimes they tend not to do much flushing because it stirs it up, and they start getting complaints. Leaving those sediments in the distribution system can actually promote nitrification. So it's a good idea when you're doing the free chlorine conversion, just get everything cleaned out of there so that you're starting with without a bunch of sediments where bacteria can multiply. So kind of think about this question. Are your booster chlorination units sized to break point the chloraminated water they treat? And obviously, if you don't have any booster chlorination, then no. And if you do have booster, have you ever tried to actually breakpoint chlorinate the water entering the booster plant? And then, as I mentioned in the appendix to the guidance manual, there's help to help you figure out, if it's not sized right size, what size do we need, etc. All right, so let's move on to planning the free chlorine conversion. It's a lot more than just turning off the ammonia feed and walking away. You need to have a source of free chlorine, and it can be either your plant, or it can, if you're a purchase system, it could be your upstream system. All the highlighted items, like the blue source here, I'll talk more about those in a minute in more detail. Source planning is different if you're a purchased water PWS and you don't have the ability to inject your own chlorine. So, it's totally different situations there to deal with. You need to have a schedule. You want to try to plan to flush the chlorine through the system as quickly and efficiently as possible. So you need to have worked out a sequence of flushing, and that's from the entry points all the way out to the ends. We highly recommend dropping tank levels during free chlorine conversion, and I'll talk more about that. And then you need to be doing more monitoring to identify how far, how much has the free chlorine progressed through the system, and then same at the reverse at the end, how far has the monochloramine gone through the system as you're trying to get back to your regular monochloramine residual. You need to have a communication plan. You're going to have both internal communications and external communications. And I'll talk about more about that in a few minutes. So coming back to the source of the free chlorine, if you have a raw water treatment plant and it's got free chlorine and ammonia feed, and that's how you're creating your chloramines, that's the easiest situation. For your source, you can turn off the ammonia in your plant, and so you start distributing free chlorine. If you're boosting, and I've already mentioned this before, pre-treated water that's coming in with chloramines, turn off the ammonia and turn up the free chlorine to get through breakpoint and make a free chlorine residual. And there again, you just have to make sure your booster plant actually has the capacity to do that, if that's the situation. If you are a purchase system and you have no chlorine feed, you have to work with your supplier to schedule a conversion. And we understand that's easier said than done with some wholesale suppliers. They may be willing to work with you or not. Just realize that if you're going to take the stance, well, we'll never get our supplier to cooperate with us, so we're just going to put in our own chlorination equipment to do breakpoint chlorination. There is a process you have to go through, engineering design and submittals and plan approval from the TCEQ. So more you can work out with the supplier just is easier for you. If you're not going to go that way, it's a harder process. So let's talk about the amount of free chlorine. When we talk about breakpoint chlorinating, we're talking about having enough chlorine in there to overcome any ammonia, monochloramine, and any free chlorine demand that's in the treated water. And in order to figure that out, you need to do some calculations. The appendix to the manual talks about that. And quite often, as I said, you may find your chlorine injector is too small to do the breakpoint chlorination. So it's just important to recognize the limitations of your existing chlorine feed equipment. All right, let's come back to sequence. So the free chlorine must be flushed from the entry points to the nearest flush points, and then move on through the system. You don't want to go and flush at the end of the system right off the bat during your free chlorine conversion. And your sequence really needs to be discussed ahead of time and not try to work it out in the field. So in order for this to work, of course, all your valves have to be working, and by valves I mean through here, both gate valves and any kind of flush valves you'll have. If you're using fire hydrants for flushing, obviously those need to be working ahead of time, and these things need to be checked. So let's look at this graph here. So when I say don't flush the furthest valve first, what's happening here at this diagram, I'm going to have it in a couple more slides too. Let's pretend your source is here on the left. Each kind of branch off of here is a separate part of your distribution system with customers, business, residential. It's not just a little line with a fire hydrant. So if you are flushing at the end, at these the other parts here where you're not flushing, you only get a little bit of chlorine going in there, and that's when you can start having problems with dichloramine and trichloramine. So it's really not a good idea to flush at the end. Instead, you flush from the source to the closest place first, then you move on to the further area, middle areas, and then finally you get to flush at the ends. All right, so let's talk about tank levels. As I mentioned before, it's a good idea to decrease the tank levels, the water levels in your tanks. And if you're a large system, and you have separate pressure planes, maybe you have the option to, lower the tank levels in one pressure plane and leave the ones in another pressure plane alone and kind of do those in series. But if you're all, in one pressure plane, you can't lower one tank without lowering the others. So you're going to have to do them all at the same time in that situation. So what's the purpose? It's really to make it quicker for the free chlorine to take over the system. If there's a lot of water in the tanks, it's just going to take a lot longer and to actually get those tanks converted over to free chlorine. So, if it takes longer, of course, that makes the conversion slower, and honestly, it costs you more in chemicals because now you're trying to convert a whole big full tank rather than, say, a smaller volume of water in a tank. So we have this example. Pretend that each of these is a tank. Going from left to right is going forward in time. So basically here in the left tank, you see chlorine or whatever coming in the lower right side of the tank, and water is exiting the left side of the tank. A few hours later, you go back and look, and you notice, okay, the chlorine, free chlorine or whatever has spread more through the tank, and then at a later point, of course, it's just a way to illustrate that it takes time. And if you were to have that full tank compared to, say, in the, that's highlighted here versus, say, have water in just half your tank, it's kind of obvious that during this process, it'll be quicker to turn over that smaller volume if you've lowered them. All right, so about monitoring. So how can you tell where the free chlorine is? You got to monitor. During the conversion, you monitor at each flush point, and you're gonna have to monitor total chlorine, free chlorine, monochloramine, and free ammonia. And you have free chlorine essentially when your total chlorine value is approximately equal to your free chlorine value, and your free ammonia value is approximately 0. So, and the reason we do all four is it's easy to get false free chlorine readings if you have monochloramine present in your system, because monochloramine interferes with your DPD free chlorine reagent and appears to look like free chlorine. So you really have to measure all four to be sure that you are dealing with free chlorine. And we've also seen situations where you have your particular water, after you go through breakpoint chlorination, there's just some residual stuff. It's like organochloramines and other stuff that still shows up in a total chlorine test, but it's not, you're past breakpoint, it's not free chlorine. And so sometimes you just have to accept that, your free chlorine is never going to equal your total chlorine exactly. But, as long as your ammonia is at 0 or, approximately 0, you can be certain that there is no free ammonia present. So mentioned communication before. You've got internal, external communications in order to make sure that this goes successfully. And when we say internal communication, we mean, if you're the operator, you're letting your managers know what's going on, and you've instructed all your operators and whoever else is helping to do the free chlorine conversion on all the procedures ahead of time. External communication, well, we would be one of those avenues for you. You need to talk to TCEQ and let us know that you're doing a free chlorine conversion. And the really, really important reason to do that is you do not want the TCEQ to come out and do their TTHM or HAA5 samples while you're in the middle of a free chlorine conversion. Because when you got free chlorine, those things are going to go out the roof. And so if you discuss it with us, and we may be able to reschedule your normal disinfection byproduct samples around that free chlorine conversion, which is a big benefit to you. Continuing with external communication, we think it's important to inform your retail customers what you're doing, telling them you're doing good things to help them have safe water, and it's really important to set their expectations ahead of time so you can limit the number of complaints you get during the free chlorine conversion. All right, another thought question here. So how long will it take to flush free chlorine through your entire distribution system, including tanks? Say you figure that out, 5 days or whatever the number is. And as I mentioned before, add that time to the conversion, both at the beginning and the end of the conversion, and that gives you an estimate of how long you need the entire conversion to last. So we said you're going to go for 2 weeks everywhere, and it takes 5 days at the front, 5 days at the back. Then you've gotten up to near four weeks or 30 days for the whole conversion. those are all kind of the highlights, but let's run through an example of a little made up public water system, Smallville, Texas, just to show how all this pulls together. So in this diagram, let's assume that they have a water source down here at the lower left, the W, and they've got a booster plant and an elevated tank right there by the source. And this is their distribution system, and it shows, if it's a city, maybe they have customers outside the city limits, that boundary, that pressure plane boundary needs to include anybody who's outside of your city limits. City limits isn't the same thing as your service area necessarily. Through the distribution system, the thicker blue lines represent, larger diameter pipes. And so where you see the thicker ones, kind of the trunk mains, and then the smaller lines out to the customers. All right, so before the conversion, you're going to check that your flushing strategy is going to work. Starting near the plant, work out to the far reaches, check all the valves you need, fire hydrants, flush points as well that you'll need. And do the operators understand which valves to open first and close, and what tests to run, etc. Plan how to drop your tank levels, and then also calculate the dose of free chlorine you're going to need. So before the conversion, as we mentioned, you want to identify the flush valves. In many cases, those will be fire hydrants, but could be other kinds of flush points that you have. And in this one, so they've figured out that they want to flush at these 9 locations. However, the numbering here does not correspond to the order in which they're going to flush. In this case, it would make a lot more sense to, start near the water source and plant here. So flush here and here first. And once you get a good free chlorine residual established at those, you can shut those fire hydrants or flush points down, and then start flushing probably 6, 7, and 8 would be next. And get a good free chlorine residual there, and close those, and then go open 3 and 4. So you can see we're kind of progressing, making our way through the system, and then get a good residual there, and then finally you do 2 and 5, kind of the far ends of your distribution system. So that would be a logical order for Smallville to do their flushing. So as you're starting the conversion, that's when you want to lower your tank levels. You're going to turn off the ammonia feed, if you haven't that ability, and then inject enough free chlorine to overcome whatever a free ammonia, monochloramine, and free chlorine demands in the incoming water. And then, of course, you begin to flush that chlorine through the system by operating valves in the sequence that you determined earlier. Got a little diagram here, or little animation to show this. So you flush sequentially near to far until the free chlorine is present. So in this, let's pretend this is just the start of the conversion. The green here is monochloramine, and pink is free chlorine. And so the free chlorine is just starting to come into the system. And, in here, you've got a mix of, maybe not free chlorine, but those dichloramines and trichloramines. So as you're flushing through, you'll get your first points flushed through in a good manner, a good residual. And then you go to the next points. And then, of course, you've got it flushed all the way through the system. So during the conversion, what are you going to be doing? You're going to be monitoring. As I mentioned, you got to monitor those 4 parameters: total chlorine, monochloramine, free ammonia, and free chlorine, until your free chlorine is about equal to the total chlorine, and your free ammonia and monochloramine are approximately 0. At that point, you've got free chlorine there. There's no point in measuring monochloramine, total chlorine, and free ammonia for the rest of the conversion. At that point. So in the middle of the conversion, all you're going to be monitoring is free chlorine. You don't need to keep monitoring those other parameters once you're sure you have a free chlorine residual. And of course, once you flush back, once you are starting to flush the monochloramine back, you'll go back and you'll have to again monitor all 4 parameters until you're sure you've got your monochloramine and total chlorine established back through the distribution system. All right, so ending the free chlorine conversion, You're going to switch back to monochloramine, and you're just going to go in the same sequence that you did before. And so now we're just starting to get monochloramine back, and it flushes through part of the system all the way to end. All right. So as far as ending the conversion, you're just going to do the same process that you did at the beginning, including lowering your tanks. That's very important as you flush monochloramine back. And then repeat the monitoring to ensure all areas are returned to monochloramine. And it's really important, this last point, write down lessons learned for your next time, because you're going to figure stuff out during this, like, oh, well, this would have worked a lot better for the next time, et cetera. So just make those notes and have those handy when you try to do your next free chlorine conversion. Also, in ending the conversion, I mentioned this already, but just reiterating, you got to monitor all 4 parameters until monochloramine and free ammonia are present. Then you go back to your normal chloramine monitoring at that point. And then let us know that you finished. So what if free chlorine conversion is not enough? You try it and it's still not working. You may need some different long-term actions that go beyond just doing these free chlorine conversions. And unfortunately, those, we don't have time to talk about those today outside the scope. But in many cases, you're going to need some professional help, because, the types of examples of long-term actions could be, if you've got stagnant areas, and dead-end mains, you may need to eliminate those. You may consider adding tank mixers or modifying your tank inlets and outlets if the tanks are part of the problem. Changing or where you're injecting or boosting may be an important way to overcome the problems you're having. This next one is, if you're in the situation where we just can't make monochloramine work, and we're going to switch back to free chlorine under normal conditions. Well, you got to deal somehow with the trihalomethanes and haloacetic acids. So could aeration help you at that point? Maybe. And are there other things? Absolutely, that might work, but it would have to be something you work out with typically with your engineer. So other tips for the free chlorine conversion: starving bacteria takes time. So again, just plan for more than just a few days of exposure to free chlorine throughout your entire distribution system. We're reluctant to allow free chlorine conversions that last longer than 30 days. So you need to make this as efficient as possible to get the most free chlorine exposure throughout the distribution system as you can. And this reluctance is based on this concept of normal versus abnormal operating conditions. We can allow high disinfection byproducts, TTHMs and haloacetic acids, for a short period that's an abnormal operating condition. But if you go beyond 30 days, we consider that now to be no longer be abnormal, but a normal operating condition. And we will not reschedule your DBP samples around a longer conversion. So can you get help with this? Our FMT providers can help you with plans for tank cycling, valve sequencing, customer communication. And kind of the overall, take-home message, I want you to get from this is, if you've got chloramines, you've got nitrification to one extent or another, and if it gets really bad, you may need to do this free chlorine conversion to stop it. But planning is essential to make the free chlorine conversion work. All right, and I think you're all going to have access to these slides. You've got my contact information there, and I like to stick in a little promotion for our FMT providers. You can reach them at fmt@tcq.texas.gov. All right, do you have any questions? Part of it is, how much can you safely lower the tank levels? A lot of times you've got, you want a full tank for fire protection, but for a short period, can you accept, tank that's half full? That's a place to start, but y'all may not be comfortable with having only a half full tank. Just do what you can and just understand, the pros and cons of having more than, the more water you have, the longer it takes to convert the tank over.